Hello, everybody. Welcome to Introduction to Networks, Module 4. So before we get into all of the good stuff here, I want to show you this quick little video. It's actually pretty funny. So let's watch this video really quick.
Hello, IT? Have you tried turning it off and on again? Oh, okay, well, the button on the side, is it glowing? Yeah, you need to turn it on.
All right. So I wanted to show you that quick little video because in the IT world, most of the items that you will come across in the IT field, even just in general, is a physical layer issue. And typically what that means is it's unplugged. Most of the time it's just not plugged in. It's physically not plugged in. Things are not working because it is not plugged in. And you will hear a lot of IT jargon in the future sometimes. Like, hey, that's a layer 1 issue. Layer 1 meaning that is a physical problem. Why is it not working? Probably because it's a layer 1 issue. Very simple. Just making sure things that are plugged in correctly. So let me give you another scenario here. You show up and your network administrator says, hey, we got a layer 1 issue here. Find it. Let's find it. Because every one of these cables are probably going to somewhere in this building, and in some small office somewhere, nobody's able to get nobody can get any internet, right? So for example, maybe this rack right here is floor number 2. This rack right here is floor number 3. This rack right here is for number 4, and you are going to need to find the physical connection to figure out what's going on here. Welcome to Module 4. This is the physical layer introduction to networks. My name is Mr. Tandy at Tandy IT, and let's get into this awesome content. So during this physical layer, we're going to talk about the purpose of the physical layer, describe the purpose of the functions of the physical layer in the network, describe characteristics of the physical layer, identify the basic characteristics of copper cabling, explain how UDP cables is used in Ethernet networks, and describe the fiber optic cables, those LED lights. And we're going to talk about other various connected media, whether it be wireless or wired. The purpose of the physical layer. So let's play a quick little game of I Spy because I want to make sure you are viewing this video. I spy a IoT device, which stands for the Internet of Things, that I just purchased at Best Buy. That could be multiple displays, anything that kind of displays something from Best Buy. I Spy. I'm expecting a lot of different answers and emails on that one. So let's get going here. Once again, the purpose of the physical layer. So before any network communicates with anything, it's got to have a physical connection. Okay, folks, it literally has to have a physical connection. So those awesome devices that you buy maybe during Christmas time, or something that you go out and get, or something that you get for Christmas that's electronic, you are going to have to plug it in. It's got to get plugged in. It's just no way around it. It's got to get plugged in. This connection could be wired or wireless, depending upon the setup of the network. This generally applies whether you are considering a corporate office or home. A network interface card connects to a device. Some devices may have just one network interface card, while others may have multiple NICs, wired or wireless, for example. Not all physical connections offer the same level of performance. That is very, very accurate. Physical layer transports the bits across a physical medium, accepts and completes data frames from the data link layer, and encodes in a series of signals that transmit to the local media. A series of signals. So don't forget that. A series of signals. That's those raw bits, those ones and zeros that are flashing. Okay. This is the last step as it encapsulates the process. This is the very, very last step. So the destination receives the bits and re-encapsulates the frame. So essentially, it's like receiving this piece of mail. So there is mail inside of this envelope. And what do you typically do with an envelope after you put some items inside of it? Yes, you are going to encapsulate it, seal it up, lick the back of it, make sure nothing comes out, and then you send it on its way. Physical layer characteristics. The physical layer standards are implemented in hardware and are governed by these organizations. So there are a lot of organizations that deal with the physical layer. IEEE is one we talk about a whole lot. We're going to talk a lot about that throughout this whole Cisco course because that deals with a lot of the physical media. And then the TCP/IP standards. These are implemented in software that are governed by the IETF. Physical layer standards address three functional areas. So we have our physical components, we have the encoding, and we have the signaling. The physical components are the hardware devices, media, and other connectors that transmit the signals transmit signals that represent the bits. So those ones and zeros that are going across that cable line, right? Hardware components like NICs or network interface cards, interfaces and connectors, cable materials, and cable designs are all specified in standards associated with the physical layer. Here's a good graphic when we talk about encoding. Encoding converts the stream of bits into a format recognizable by the next device in the network path. Encoding converts the stream of bits into a format recognizable by the next device in the network path. So that's very similar to, let me pull the pen out here. Convert stream into bits recognizable by the next device. So if we had Mr. UPS truck here, or Mrs., just put in UPS here, and it just left your house, right? Your wonderful home, because you walked outside to the mailbox to drop mail in. Oops, I forgot to put tires on my UPS truck. So encoding converts the stream of bits into a format recognizable by the next device in the next network. So UPS truck takes off and it goes to the little hub, and somebody may offload all of the contents on the truck, i.e. data, and another truck may have the exact route on where that package needs to go. Or in other words, next device in the network path, something that's recognizable, right? This coding provides predictable patterns that can be recognized by the next device. Examples include methods including Manchester. Okay, let's move on to the next one here. If you've been watching my other videos, you know that the binary code, the ones and zeros, when either the light is on or the light is going to be off, right? If it's on, it's getting a 1. If it's off, it's going to get a 0. Bandwidth is the capacity in which a medium can carry data. I'm going to give you a cool representation of that here in a second. Digital bandwidth measures the amount of data that can flow through one place to another in a given amount of time. How many bits can be transmitted in a second? Physical media properties, current technologies, and laws of physics play a role. Absolutely. So take a look at this. You may have heard a lot of these acronyms, gigabits per second, or megabits per second, kilobytes. This is essentially all the breakdowns on how those equate to each other. Now, bandwidth terminology. Latency, the amount of time, including delays for data that travel from one given point to another. Throughput, the measure of the transfer of the bits across the media, given a period of time, the measure. And then Cisco talks about good put, which is all the measurable data, the ones that the actual data that can actually be used. So to kind of best represent this, let me change this graphic here so you can see this here. Hopefully you guys can see my screen here. All right, let's change it to this darker color. All right, so I'm going to draw a picture of a freeway. Here's a picture of the freeway. And just for the fun of it, we'll name it a freeway here in Southern Cal. Let's call this the 91 freeway. So this is the 91 freeway. Remember, we're talking about latency, throughput, good put, bandwidth, all that good stuff here, right? So I'm going to give you a little scenario here. Let's say, for example, it's about 1 o'clock p.m. in the afternoon, and we're on the 91 freeway. Let's say the 91 around maybe the 215 freeway, 15, around in there. How fast do you think how fast do you think traffic is going? How fast do you think traffic is going at that time? Send me an email. Let me know what you think, how fast traffic is going during that time. Let's say, for example, traffic is moving about 60 miles an hour. Now, what I'm going to do is I'm going to draw some little cars on the freeway. Okay. These little cars on the freeway. And let's go this direction here. So we have the opposite side too. This will be little cars. Now, don't laugh at my cars, okay? Like I said, I'm not the best draw artist in the world. I mainly deal with IT type of items, cybersecurity, all that good stuff, not artistry. But that's okay. Here we go. All right. So 1 o'clock in the afternoon, cars are going probably at maybe about 60 miles an hour. Now, what I want you to understand is this. When we talk about bandwidth, I want you to imagine that both ends of this freeway is a big Ethernet cable. And the bandwidth measures the width, like the size of the internet connection, right? That's the size. And we put the word bandwidth. So I'll just put the word band right there. So the bandwidth represents the size of this freeway. The throughput is essentially the cars that are moving on the freeway. These are all the cars on the freeway. Now, Cisco talks about the measure transfer bits across median time, latency. So let's talk about latency. I'm going to give you the definition of latency. It's the amount of time including delays. Okay, let's talk about delays. Because if you're in Southern California and you're dealing with traffic in California, you know that there is a lot of delays. Just for some stupid reasons, too. There's just a lot of delays. So let's talk about latency. So any given time, like I said, this freeway is moving about 60 miles an hour. Let's say, for example, that, let me put some more cars on the freeway here. What if there's a big rig right here in the number 2 lane that just breaks down? How do you think the throughput is going to be moving now? How do you think the data packets are going to be moving on the freeway? Do you think that's going to slow? You think it's going to slow down 60 miles an hour? Or you think it's going to go a little bit faster? More than likely, this side of the freeway is still going to continue to move. Maybe this side is going to slow down, but this side may stay the same. So what happens if another car on the other side were to break down? What happens if another car were to break down? What happens if Caltrans is out there on the freeway? If you're watching this video from somewhere out of California, Caltrans is the state department that deals with all the roads in the state of California. What happens if they just completely shut down one of these roads? What's going to happen with our throughput? Right, we're going to have latency, or we're going to have delays. We're definitely going to have delays. So when you think of bandwidth, I want you to think of the size of the connection, which is essentially this the width of the freeway. And then when we talk about throughput, I want you to think of all of the data packets that are moving within that connection. And now another idea that I talk about here is goodput. Now goodput, it says the usable data. So essentially, if any one of these cars or data packets is good for good use, right? It's got a good idea how that's a good way to think about when we think about bandwidth, latency, and throughput. Copper cabling. Copper cabling is the most common type of cabling used in networks today. It's inexpensive, easy to install, and has low resistance to electrical flow. Attenuation. The longer the electrical signals have to travel, the weaker they get. So essentially like throwing a ball. The longer that ball has to go down without anybody catching it, the weaker that power is going to get. The velocity of that ball is going to get a little bit weaker. The electrical signal is susceptible in interference with two sources, which can distort and corrupt the data signals. So we have EMI and radio frequencies, or crosstalk. Radio frequencies. This is also something that we use all the time when it deals with Wi-Fi, right? Deals with Wi-Fi. Mitigation, strict adherence to cable length limits will mitigate attenuation, so makes it so that information gets there really quick, or that ball can get there as fast as possible without losing any power. Some kinds of copper cable mitigate EMI and RFI by using metallic shielding and grounding. So you want to essentially, that's basically putting like a protective shell so that signal can be nice and strong inside of that cable as it sends that data. Some kinds of copper cable mitigate crosstalk by twisting opposite circuits or pairs together. Now, you probably have seen these before. I'm not sure if you have, but these are different types of copper cablings we have. The most copper cabling that we are very familiar with would be this UDP cable, this unshielded twisted pair. This is a shielded twisted pair. Take note of the metal. Excuse me, I say metal, I'm sorry. Take note of the little foil type substance inside of it. This kind of shields the signals that are going in and out of this cable. This one does not. This is a coaxial cable. So if you have a modem at home, you have a modem. By the way, hopefully you're watching this video. Send me the definition of a modem. Tell me exactly what a modem does. Send me an email on that. I want to know what a modem does. Essentially, you probably have this cable plugged in to your modem. This is probably coming from the street. This is pretty basic. This is inexpensive. This is what I have here in my house. This is plugged into my modem, and then I plug it into my Soho router here at home. Once again, send me an email. I want to know what a modem is. So unshielded twisted pair, or UDP, is the most common network media, terminated with a RJ45 connection. RJ45, very important, RJ45 connections. Key characteristics of UDP: the outer jacket protects the copper wires from physical damage. Duh, we don't want the cable to get messed up. Twisted pairs protect the signal from interference. Color-coded plastic indication electricity isolates the wires from each other and identifies each pair. So each one of these does something very specific as it carries the data. I also want you to think of this. You know, I'd like to definitely bring in the real world things that we do on a daily basis as it comes to this material. It kind of helps things learn a little bit. I want you to think of these little cables of different types of avenues, and they all are assigned to do a role. They all have a role. Twisted pair, shielded twisted pair, better noise protection. It is pretty expensive. It is terminated with RJ45 connections. And some of the key characteristics: the outer jackets protect the cable wires from physical damage, braided in foil, and it has a lot of EMI or RFI protection. So it protects it from those signals. It's kind of like a tunnel, going through a tunnel, protected from the outside, right? Oh, sorry. Go forward here. These are BNC connections, or some copper cables. Consists of the following: outer cable jackets prevent minor physical damage. A woven copper braid or metallic foil acts as a second wire in the circuit as a shield for the inner conductor. So take a good look at it. This is how these connections are with these BNC connections, right? With these coaxial cables. UTP cabling. The properties of untwisted pair have 4 pairs of color coded on the copper wire. These are the four color codes. Remember, I told you I want you to think of these as roads. They all do something very similar, but they need to work together. No shielding is used. UDP relies on the following properties to limit crosstalk. Cancellation. Each wire in a pair of wires uses opposite polarity. One wire is negative, the other wire is positive. They are twisted together in magnetic fields, and they cancel each other out, which is pretty cool. Variation in twists per foot each wire. Each wire is twisted differently, has different amounts, which helps prevent crosstalk amongst wires in the cable. Got to know these standards. This is very, very important. Whether you're finishing up our CCNA or you're going to take the Network Plus, you have to know these standards. Very, very important. Standards for UDPs are established by the TIEA, EIA, T56A, and T56B. I know it doesn't say that on here, but I just know that. Those are 2 different types of standards. I'm pretty sure it's coming up in a couple slides, but just wanted to bring that up here. So these are the different cable types, the different connectors, and different terminations. Again, each one of these cables represent roads, and they all work in conjunction with each other. Electrical standards for copper cabling are established by the IEEE, which rates cables according to the performance. So we have a Category 3, Category 5, and 5E, and a Category 6. Now, I will tell you, what you can do is if you're watching this video, pause it. It just depends if you're watching this with wireless, but if you have a Ethernet cable plugged in, if you actually look on the cable, you can actually see if there is if it's a Category 5 or a 5E. It is actually listed on the cable. And here's a good example of that. Hopefully you can see that here. This is a UDP cable. This is a Cat 5E, and it's actually listed on there. It tells you the type of cable this is. UDP cable standards and connectors, like we talked about, an RJ45 connection. This is an RJ45 socket. Each one of those wires, they all have a little avenue. Like I was telling you, they all do something very specific, but they all have to be terminated into these little wires. This is a little RJ45 socket. Essentially, this is what this plugs into. I don't know if you can see those little fins right there. That's what transmits that data through that cable. Oh, let me go back here. I do want to point this out. Now, in the IT world, sometimes in the past, I remember getting work orders when I used to work in IT of intermittent internet, or maybe some data packets are not coming in like it needs to, or things are not working. Sometimes they can get access to things, sometimes they not, and you do a check on the computer, everything looks fine. But more than likely, I don't know if you see the difference between the two. As you can see, this one is poorly terminated, and this one is terminated correctly. Most of the time, when you see this in the industry, this is because the cable is not properly zip tied down to the table somewhere, and it's just laying on the ground. And then next to their office chairs, they run these over, and it just pulls everything apart, and it's not. It just causes a lot of issues. Again, layer one. Going back to what I said earlier in the video, Most of your issues, most of the challenges that you'll get, especially in IT world, are going to be layer one problems, typically layer one problems. So UDP cable, straight through and crossover UDP cables, take note of these numbers and the different colors. So this is what I was explaining to you about each one of these little cables. They all have a purpose. Ethernet straight through cables, both ends, T56A or T56B, host to network devices. Ethernet crossover cables, one end is T56A, and the other end is T56B. It's like a host to host, switch to switch, and a router to router. So these cables are very important, especially when it comes to Cisco Packet Tracer, because you have to be able to select these cables. And I'm going to open my Packet Tracer up so I can show you that. Okay, here's my Packet Tracer at the time. So to get to those cables, you're going to click on this little lightning bolt connections, and here are all the cables here. Now I will challenge you. Here's a challenge for you. Typically in all the Packet Tracer labs, it won't allow you to do this one because this one actually picks the correct cable for you. Challenge yourself. Try to figure out which cable to use in a certain application. So, this is a console cable. This is the cable that you're going to use to console into a switch used from the computer. This is a copper straight through cable. These are the crossover cables. We have a couple fiber, coaxial cables, and things of that nature. Cabling is very, very important, especially when it comes to networking. You have to have a good grasp on how these cables work and what exactly they do, especially when it comes to specific applications. Very, very important. Fiber optic cabling. Properties of fiber optic cabling. So not as common as UDP because of the expensive involved. It's pretty expensive. Having fiber optic cabling is pretty expensive. Ideal for some networking scenarios, transmits data over longer distances at higher bandwidth. So there's that word. There's that higher bandwidth, right? There's that wide freeway, all that throughput goes through. Than any other networking medium. Less susceptible to attenuation. So remember throwing that ball, getting that ball so it has all kind of energy to get to where it needs to. So it's very less susceptible to that, meaning that you use fiber, it's going to get there without any challenges typically, not unless there's a break in the line, right? And completely immune to EMI RFIs. You don't have to worry about those radio frequencies getting involved when it comes to any type of signal dropouts when it comes to fiber. Uses a laser or LED to encode bits as pulses of lights, right? So uses those lasers, which is pretty cool. Fiber optic cabling acts as a waveguide to transmit light through the two ends with minimal signal loss. Very, very cool. So these are some different types of fiber. Again, can't stress enough. If you are going to get your Network Plus doing the CCNA, you need to know the two different types of fibers that are out there because they all do things very differently, but they're very similar, but they still do things different. Some of them are stronger than others. Single mode fiber, very small core, uses expensive lasers, long distance applications. And then multi-mode fiber, larger core, uses less expensive LEDs. LEDs transmit in different angles up to 10 gigabits over 550 meters. Pretty good. Dispersion refers to the spreading out of light pulse over time. Increased dispersion means increased loss of signal strength. Multi-mode fiber has greater dispersion than single-mode fiber, with the maximum cable distance of with the multi-mode fiber of 550 meters. You will see some scenarios that deal with these ideas with these meters and how fast, how long these cables can transmit and things of that nature. Fiber optic cabling is now being used in 4 types of industry: enterprise networks, fiber to home, long haul networks, and submarine cable networks. So these are different types of connectors when it comes to fiber. We have our ST connections, straight tips. We have our LC connections. We have our duplex mode LC connections. Notice this, essentially there's two of these together for the duplex mode. And then we have our SC connection, subscriber connector. SC, like in Southern California Trojans. Just kidding. So these are different types of patch cords. You may see these in a networking closet. A yellow jacket is for single mode fiber cables, and orange or aqua is for multi-mode cables, for multi-mode fiber cables. Take note of the different types of cables. Optical fiber is primarily used as a backbone cabling for high traffic. Point-to-point connections between data distribution facilities and for the interconnection of buildings and multi-building campuses. So this kind of gives you a breakdown of the different type of challenges that may come with putting these cables in. And as far as like how fast they are and strong they are and things of that nature. Really good graphic here. Let's talk about wireless media, or known as Wi-Fi. Properties of wireless media: it carries electromagnetic signals representing binary digits using radio and microwave frequencies. This provides the greatest mobility option. Wireless connections numbers continue to increase. That is exactly right, right? Wireless, having to be able to use wireless is very, very, not only does it help the availability of being able to get onto the internet as quick as possible, but it definitely helps those situations where you can't run cabling to certain areas of the room because you just can't get there, or there's something blocking anything. Sure, throw an access point right there, get you some Wi-Fi, transmits those binary digits using radio frequencies, you're good to go, right? So that's some of the benefits of wireless. Some of the limitations of wireless: coverage areas. Effective coverage can be significantly impacted by the physical characteristics of deployment of location. Let's talk about this, for example. I specifically remember during COVID, I know everybody unfortunately remembers our COVID situation in 2020. I was working help desk with my position I was at, working for the school district. And we would get a lot of phone calls about their internet at home not working. So essentially, we were there to support them as far as the device was concerned. However, when their internet's not working, their device can't work. So we have to do a little extra troubleshooting. I can't tell you how many times I would ask, where exactly is your router? Like, where is your access point that's giving you your internet? They would tell me that it's in their kitchen. Okay. Here goes my next question. If it's in your kitchen, what else is in your kitchen? And I'll ask you that question as well. Email me something in your kitchen that uses radio frequencies that could definitely disrupt a Wi-Fi signal. Definitely disrupt the Wi-Fi signal. Interference. Wireless is susceptible to interference and can be disrupted by many common devices. Security. Wireless communications coverage requires no access to physical strand of media, so anyone can gain access to the transmission. I don't exactly agree with that, because you can add passwords to that, right? You can make it so nobody can get on that. But I understand what you're talking about. Wireless local area networks operate in half duplex, which means only one device can send and receive at a time. Many users accessing the wireless local area network simultaneously results in reduced bandwidth for each user. The IEEE and telecommunication industry standards for wireless data communications cover both the data link and the physical layers. That is layer 1 and layer 2. All deal with IEEE. In each of these standards, physical layers specifications dictate the data, the radio signal encoding methods, frequency and power transmission, signal receptions, antenna design, all that good stuff. Folks, make sure you understand this right here. This is a big one. Wi-Fi, 802.11. That is the standard that gives you Wi-Fi. Bluetooth uses 802 802.15, wireless personal networks, WiMAX IEEE 802.16, and then Zigbee 802.15.4. Low data rate, low power consumption in communications. Let's talk about wireless local area networks. Wireless access point. Concentrate wireless signals from users and connect the existing copper-based infrastructure. So again, being able to use an access point in a situation where you can't have a hardwired connection, where you can't run that Ethernet cable with that RJ45 connection on the back of it. You're going to use an access point. Now, wireless NIC adapters, this is pretty cool. This actually is a dedicated peripheral that goes into your device or into your computer. Sometimes those wireless NICs, they can get out to the internet. So if you have an access point in your computer, if you have an access point in your house, the wireless NIC essentially will send those raw bits and connect to that access point, kind of like how your phone would connect, which is pretty cool. There are a number of wireless local area network standards. When purchasing a wireless local area network equipment, ensure capabilities and interoperabilities. Network administrators must develop and apply stringent security policies and processes to protect wireless local area networks from unauthorized access and damage. All right, ladies and gentlemen, that's going to close out Module 4, the physical layer, Introduction to Networks. See you on the next video.